we're picking three different numbers from a list of 10. And so actually the first thing to figure out is how many that gives us. In fact, it is 10C3. That's precisely what this is, combinations. Pick three things from 10, the order does not matter. And that becomes, technically it's 10 factorial over 7 factorial, 3 factorial. You can cancel that down to 10 times 9 times 8 times 7 factorial. See, these two will then cancel, times 3 times 2. Now let me say a little bit more about this because I want to kind of explain where 10C3 comes from if you weren't aware. So basically there's going to be 10 options for the first number, and then 9 options for the second number, and then 8 options for the third number. But here's the thing, it doesn't matter if we pick, say, 135 or 153. We're still interested in just one of them being the mean of the other two. So we need to divide by the different permutations that you can have for your three numbers. And that is where the 3 times 2 times 1 come from. So it kind of explains where the simplification comes from. And we just normally then write it as 10C3 because that's what it always becomes. So in our case, it's going to cancel down. So the 9 and the 3 are going to cancel down to the 3 here, the 2 and the 8 to 4. So I've got 12 times 10, got 120 different options here. Right, so now we need to look at the different ways that we can get one of the numbers being the mean of the other two. So I'm going to just work systematically through this, looking first of all whether 1 might be combined with another number. So 1 and 3 will make 4, which the mean is 2, so that's not going to work. 1 and 5 is going to give me 6, which is then going to give me a mean of 3. So I'm just going to write down the first two numbers, not the actual mean, because we know that we can combine 1 and 5 with one of the other numbers, and yeah, that will work out. So although maybe I should just in case two of them. No, I think this is okay. I'm going to write it down though, just to be safe. So then 1 set and 7 will give me 8, which will give me an even number of 4. So I can kind of skip that and jump straight onto the 9. So that will give me 1, 9, and the mean will be 5. Then 1, 13, and the mean will be 7. You can sort of see this pattern emerging. 1, I can ignore 15, 17, and then 9. Okay, that's going to be all the different ways with 1. Right, next up, what about with 3? So 3 and 5 won't work, but 3 and 7 will give me 5. 3 and 11 will give me 7. And 3 and 15 will give me 9. And 3 and 19 will give 11. Okay, that's good. All right, let's do 5. 5 and 7 won't work, but 5 and 9 will give 7. 5 and 13 will give 9. 5 and 17 will give 11. So I just get 3 here. I've already sort of got 5 elsewhere. This is fine. Let's do 7 and 11 will give me 9. I was thinking, like, could you possibly ever double count it? But I don't think you can. It's always going to be uh, in between the first and the second number. It's not like we can get 11 and 9 and then give me a mean of 7 or anything. Anyway, 7 and 15 give 11. 7 and 19, 13. Okay, 9 and 13 give 11. 9 and 17 are going to give 13. And that's it here. 11 and 15, 13. 11 and 19 give me 15. 13 and 17 will give 15. That's it. 15 and 19 give 17. And I think we're there. So we're getting 8 from these two. 6, 7, 8 from these on the right, and then another 4 here. So 8 plus 8 plus 4 is going to give 20. So that means it's going to be 20 over 120, which I can simplify to 1 over 6. So 120 over p is going to be 120 divided by 1 over 6, which is the same as 120 times 6, and therefore that's going to give 720.